Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, we are going to discuss some questions related to hybridization and orbital overlapping. So before that, let's recap what we have learned about hybridization. So we have 5 types of hybridization. The first one is SP. SP hybrid is a mixing of S and P orbital. Okay, and then we have sp2 hybridized, which is the mixing of s orbital, one s orbital and 2p orbital. Okay, number 3 is sp3, which is the mixing of one s orbital and 3p orbital. Number 4, we have sp3d, which is the mixing of one s orbital, 3p orbital and 1d orbital. And the last one is sp3d2, which is the mixing of1s, 3p orbital and 2d orbital. Okay, so this hybrid orbital have their own shape. Okay, the shape of hybrid orbital is based on the basic molecular geometry. So for sp hybrid, the shape is linear. Okay, the shape is linear. So how to draw the orbital, sp orbital should be in linear shape. Okay, so this is sp orbital. And then for sp2 orbital, the shape is trigonal planar. Okay, so we draw trigonal planar shape. And then for sp3 is tetrahedral. One, 2, 3, 4. For tetrahedral, since we have 4 orbitals involved, 1, 2, 3, 4, so we need to have 4 lobes. Okay, so for sp3d, the shape is trigonal bipyramidal. So sp3d is a mixing of 5 orbitals. Okay, so we need to have 5 loops. Okay, so in trigonal bipyramidal shape, 1, 2, 3, 4 and 5. Okay, and the last one is octahedral for sp3d2, which is the mixing or combination of 6 orbitals. So we need to have 6 loops in octahedral shape. 1, 2, 3, 4, 5, 6. Okay, so let's discuss tutorial question 4.3, question number 3. Okay, describe the type of hybridization of the central atom of in the following species. Show the orbital overlapping diagram. So we have 2 questions here. First, to describe the type of hybridization of the central atom. Number 2, to show the orbital overlapping. So since the question asks you to describe, means you need to give some explanation about the type of hybridization. You cannot just state the type of hybrid. Okay, and then for showing the orbital overlapping, we need to draw the orbital overlapping. Okay, this one you need to explain. Okay, so let me choose B and F. Okay, so we start with Bh3 molecule. So to describe the type of hybridization, First, we need to draw the Lewis structure of Bh3. So Bh3, the total number of valence electron is the total is 6. Okay, draw the Lewis structure as a boron at the central atom bonded to 3 hydrogen atoms. Okay, so duplet for each hydrogen atom. Boron haven't achieved octet configuration, but since boron included in incomplete octet, okay, we have 3 elements that involve in incomplete octet, the exception for octet rule, which is boron, beryllium and aluminium. Okay, so this is the most stable structure for Bh3. Okay, from the Lewis structure, identify the molecular shape. So since we have 3 electron pairs around the central atom, which are all bonding pairs and no lone pair, so the molecular shape for Bh3 is trigonal planar. So we draw the shape of trigonal planar. Okay, so to determine the type of hybridization, so we focus on the Lewis structure. Okay, in the Lewis structure, we have 3 sigma bond around the central atom. So in order to identify the type of hybridization, you need to count the total number of sigma bond and lone pair. Okay, so there are 3 sigma bond and no lone pair. Okay, therefore the type of hybridization is sp2. Okay, and then we need to draw the valence orbital diagram for both the central atom and terminal atom. Valence orbital diagram means the orbital diagram for the valence electron. So for the central atom, which is boron, the ground state, okay, the initial state, the ground state is, okay, we know that boron has 3 valence electron, and the 3 valence electron is in 2s and 2p orbital. Okay, and then the excited state, this is excited state. And hybrid. Okay, so ground state for boron is 3 valence electron, means we have 2 electrons in opposite direction in 2s orbital and 1 electron in 2p. Okay, this is the ground state. The original electronic configuration for boron, for the valence electron. Okay, for excited state, what we need to do is to look at the Lewis structure. Okay, check how many sigma bond and the pi bond involved around the central atom. So we only have 3 sigma bond, means boron need to overlap with hydrogen 3 times. Therefore, we need to have 3 unpaired electrons here. Therefore, since the hybridization is sp2, so we just mix 1 s orbital and 2p orbital to be sp2 hybrid. Okay, we have an empty orbital here. Okay, and then the valence orbital diagram for the terminal atom, which is hydrogen, is 1 electron in 1s orbital. Okay, this is for describe the type of hybridization. In order to draw the orbital overlapping, we must make sure that the drawing of orbital overlapping must be similar with the shape of the molecule. So we draw trigonal planar. Okay, this is for boron, which is the central atom. Okay, this is sp2, labeled sp2. Okay, each orbital brings 1 unpaired electron. Okay, and then boron will overlap with hydrogen atom. Okay, hydrogen is spherical since the orbital is 1s. Okay, so this is 1s orbital, hydrogen. Okay, so each hydrogen atoms bring 1 electron. So overlapping between boron and hydrogen will form a sigma bond. Okay, so this is the overlapping for BH3. Okay, next we are going to discuss for Icl2 minus. So as usual, we are going to start with the Lewis structure. So the total number of valence electron for Icl2 minus is, okay, remember to add 1 electron since we have the -1 charge here. So the total of the valence electron is 22. Okay, iodine as the central atom, we bonded to 2 chlorine atoms. Okay, 22 minus 4, so we have 18 electrons here to distribute to the terminal atoms. Okay, make sure the chlorine atoms achieve octet configuration first, and then 18 minus 12, we have another 6 electron to be distributed to the central atom. So 6 electron means we are going to have 3 lone pairs on the central atom. 1, 2, 3. Okay, the -1 charge, so put square bracket and negative charge. So this is the Lewis structure for Icl2 minus. So the molecular shape is linear since we have 2 bonding pairs and 3 bonding pairs around the central atom. Okay, this is for molecular shape. Okay, now to identify the type of hybridization, count the total number of the lone pairs and sigma bond around the central atom. So we have 2 sigma bonds here and we have 3 lone pairs. Okay, there are 2 sigma bond and 3 lone pairs around the central atom. Therefore, the type of hybridization is 2 plus 3, 5. So SPPPD. It is sp3d, a mixing of 1 s orbital, 3 p orbitals and 1 d orbital. So for the valence orbital diagram, the central atom is iodine, the ground state. You need to remember that if the question gives you ion, either it is cation or anion, we need to calculate the formal charge for each atom to make sure the number of the valence electron. So look at the Lewis structure. The formal charge for iodine is iodine 7 valence electron minus 3 lone pairs means 6 electron, and we have 2 bonds here, so 7 minus 8. 7 valence electron minus 8. So the formal charge for iodine is -1. For chlorine 7 valence electron minus 1, 2, 3, 4, 5, 6, 7. So 7 minus 7, 0. So the negative charge for Icl2 minus is actually on iodine or the central atom, -1. So to draw the valence orbital diagram, so iodine here should be I minus. So the valence electron for iodine is 7. This is 5s and 5p. We have 7 valence electron originally, 1, 2, 3, 4, 5, 6, 7. 7 valence electron. But since iodine carries -1 charge, means iodine has received 1 electron. So here we have 8 electrons. 8 valence electron in I minus. So this is the ground state. How about the excited state? Remember, for excited state we need to count the total number of sigma bond and pi bond. In this case we don't have pi bond. Pi bond only exists in multiple bond, which is double bond and triple bond. So in this case we have only 2 sigma bonds. 2 sigma bond means iodine will overlap 2 times with chlorine atoms. So for excited state we need to prepare 2 unpaired electrons here. So in this case we need to excite 1 electron from 5p to 5d orbital. 1 electron excite to 5d orbital. Why? Because we want to prepare 2 unpaired electrons for overlapping in Icl2 minus. So we have three lone pairs and 2 unpaired electron. Okay, so if we compare our excited state with our Lewis structure, okay, it is similar, means we have 2 unpaired electrons here for the formation of sigma bond, and we have 3 lone pairs here, okay, on the center atom. Okay, so for the hybrid orbital, okay, we have identified just now the hybrid is sp3d, so we just mix one s orbital with 3 p orbital and 1 d orbital, okay, forming sp3d. So 3 lone pairs and 2 unpaired electrons. The valence orbital diagram for chlorine is 7 electron in 3s and 3p. 1, 2, okay, 7 electrons in chlorine. Okay, we need to draw the orbital overlapping since the hybrid is sp3d. Okay, the hybrid orbital for sp3d is trigonal bipyramidal. So how to draw the trigonal bipyramidal? 1, 2, 3, 4, 5 loops for trigonal bipyramidal. So this is sp3d. Okay, label all the orbital sp3d. Okay, so we must know the molecular shape of Icl2 minus. Just now we have predict the molecular shape is linear, so you need to draw the overlapping must be in linear shape. So I, this is I minus, okay, it will overlap with chlorine atom, and the orbital for chlorine atoms is 3p orbital. So we can draw p orbital, okay, overlap. So this is 3p, 3p and chlorine. Okay, I minus bring 1 electron and chlorine atom brings 1 electron. So the overlapping between these 2 atoms will form sigma bond. Okay, and the other 3 orbitals here is a lone pair, so we must put 2 electrons in opposite direction. Put the negative charge here, the negative 1 charge here, okay, label as I minus, or otherwise you need to put square bracket and negative charge here. Alright, okay, so this is Icl2 minus and the molecular shape is linear. Okay, that's all for today's lesson. Thank you.